Hello everyone, welcome to the Electron Flow Academy. So our today's topic is based on the transformers, self-induced EMF and mutual-induced EMF. So we are going to solve the numerical problem based on that topic. Okay, so question is given to us is that two coils A and B are wounded on a common magnetic core and are tightly coupled. Okay, so there are two coils, coil A and coil B. So the coil A have 500 turns and coil B has 3000 turns respectively. Then a current of 5 ampere in a coil A produces a flux of 0.6 milliweber. Okay. And if the current in coil A gets reversed in 0.2 seconds, there is time is given to us. If the current of the coil A is get reversed, then determine the average induced EMF in coil A and B. Okay, so this is the question is given to us. So let's start the solution. Okay, so firstly we are here writing the given parameters. Given first thing is that N1 is 500. Okay, number of turns. So 1 here meaning coil A. Okay, and 2 is here meaning coil B. So N2 is given 3000 turns. Next, phi1 is 0.6 milli 10 to the power minus 3, okay, Weber, and I1 is given to us is 5 ampere. Okay, so those parameters are given to us. Next thing is that firstly we will calculate the self-induced self-inductance of coil A. Okay, so let's L1 is the self-inductance of coil A. So the formula of the self-inductance, we know that N1 multiplied by phi1 divided by I1. Okay. So with the help of this formula, we can calculate the self-inductance of coil A. So here L1 is equal to 500 into 0.6 into 10 to the power minus 3 divided by 5. Then L of 1 is equal to, I get the value of L1 is 0.06 Henry. Okay, so this is how I calculated the self-inductance of coil A. Okay, next thing is that induced EMF in coil A, induced EMF in coil A is self-induced EMF. Okay, so here induced EMF in coil A is written by EA. Okay, so the formula of the induced EMF is equal to negative of L1 multiplied by di1 upon dt. Okay, so this is the formula of the induced EMF. Okay, next thing is that here we need to calculate the rate of change of current. Okay, so current changes from 5 ampere to minus 5 ampere in 0.2 second. This is given us in the question here. If the current gets reverse means the minus 5 ampere gets reversed in terms of, sorry, 5 ampere gets reversed in terms of minus 5 ampere in 0.2 second. Then that means here del of I is equal to minus 5, meaning minus 10 ampere. Okay, and del t is given us 0.02 second. Okay, then the value of the EA is equal to now here L1, we already calculated the L1, which is equal to 0.06, and DI meaning minus 10 divided by dt meaning 0.02. Okay, so let's calculate the EA. So EA is equal to now minus L1 di by dt. Okay, so the value of the L1 is negative 0.06 into di means minus 10 divided by 0.02. So this is how we have calculated the induced EMF in coil A. So the value of the EA I get here is 30 volts. Okay. Next thing is that here induced EMF in coil B, okay, is due to mutual inductance. Okay. So the formula of the mutual inductance is given by EB is equal to minus M di by dt. Okay. So here we know that M is equal to N2 phi 2 divided by I1. Okay, this is the formula. So in this question, since two coils are tightly coupled, here given us that two coils are tightly coupled. Okay, this is given us in the question here, tightly coupled. Okay, that means phi 2 is equal to phi 1. Okay, and their meaning is that no leakage flux. No leakage flux. Okay, so meaning of the tightly coupled is here is that phi 2 is equal to phi 1. So let's calculate the firstly mutual inductance M. So M is equal to here N2 phi 1 divided by I1. So here I write the phi 2. But because of the given condition phi 1 is equal to phi 2. So I equation of M which is equal to N2 into phi 1 divided by I1. Okay. So the value of the M is equal to N2 given us 3000 turns multiplied by phi 1. Okay. So we have calculated the value of the phi 1 which is equal to here 0.6 into 10 to the power minus 3. So 0.6 into 10 to the power minus 3 divided by I1 which is equal to 5 ampere. Okay. So the value of the mutual inductance I get here is 0.36 Henry. Okay. So this value of the M will help us to calculate the EB. Okay. Induced EMF in the coil B. So let's calculate the EB now. So EB is equal to now minus M di by dt. Okay, so let's put the values minus of 0.36 into di, we have calculated that, which is equal to minus 10 here. Okay, and divided by dt. dt is given us that 0.2 second in the question. 0.2 second. Okay, so the value of the EB is now 180 volts. Okay, so what we have calculated here, we have determined the average induced EMF in coil A and coil B. Okay, so this is the average induced EMF of the coil A is 30 volt, and the average induced EMF in the coil is B is 180 volt. Okay, so this is how we have calculated the self-induced EMF and the mutual induced EMF. Okay, so thank you very much. Please like and subscribe our channel.